So, what are we going to talk about today?
Well, today we're going to talk about something that is not totally different than what we've been talking about, but it's going to be a little bit of a step away from the conversions that we have been doing.
Okay.
We're going to be talking about something called molecular and empirical formulas.
Sounds kind of intense.
It is a little bit, so we're going to kind of take it. We're going to take it a little bit slow.
Okay.
So we're going to go ahead. Let's start out by defining what empirical and molecular formulas are.
Okay.
And so if we take a look, the molecular formula of something is the formula that shows the actual number of atoms. So like some of the things that we're going to be looking at in a little bit, if we've got something like that. That would be the molecular formula because that is actually how many carbon atoms and how many hydrogen atoms that we have in that substance.
So, I mean, if I could look at it, I would see 2 carbons and 4 H's.
Yes.
Okay.
Yeah. Now we can take something, we can take that idea and talk about the empirical formula, which is the formula that shows the lowest molar ratio.
So does that mean I should reduce them if it's the lowest?
Right. So, yeah, so we may want to reduce it. Now, before we kind of get into that, the molar ratio is the ratio of the subscripts. So, for example, we've got a picture of this molecule right here. How many carbons do you see?
All right, so I see 1, 2, 3.
All right. So off to the side, we can just write that in. We've got 3 carbons, and then how many hydrogens do you see?
All right, so if we're going to start right here, I've got 1, 2, 3, 4, 5, 6.
All right, so we've got 6 hydrogens. So then the molecular formula would be the actual number of atoms that we have. So we've got
C3, H6. Wow, this is super easy. I thought this was going to be much more intense.
well, okay, keep that in mind.
Okay.
Keep that going with you. Okay, the molar ratio would be the ratio of the subscripts. So the subscripts that we have are the 3 and the 6. So we would put 3 over 6 because that's how we do ratios.
Okay.
Now, the empirical formula is the lowest molar ratio, so we want to look at that 3 over 6 and see, can we reduce it?
If I divide each number by 3, I could reduce it down to 1 and 2.
Right, because that's 1/2, 3 is half of 6. So the molar ratio would be 1/2, and then the empirical formula would then be the lowest molar ratio. So if we say that 1 was the number of carbons and the 2 is the number of hydrogens, we would use these as the new, I'm going to stop being fancy. We're going to use those as our new subscripts. So now we've got one carbon and 2 hydrogens. So the CH2 is the empirical formula.
This seems pretty easy.
Okay, not too bad. So, all right, so let's try one more to see how we're doing. So I've got C6H12O6.
So they already gave us the molecular formula, so we didn't have to count them.
Right, so all we want to do is we want to figure out the molar ratio and the empirical formula. So if we want to write it out, we can do...
So my ratio would be 6 to 12 to 6.
12 to 6. Yeah. Now, if I take that, can we reduce those numbers? Like, if I've got like 6 over 12.
Well, I could divide them all by 2, but then if I divide them by 2, then that would be 363, and that can go even further. So I got to divide them all by 6.
All right.
Right?
So if we divide them all by 6, we can do 1, 2, 1. All right. So that would be our molar ratio, and then we can take that to make our empirical formula, which would be CH2O. Okay, not too bad, right?
Yeah.
I like this. I hope they're all like this.
A lot of them are. Tell you what, why don't you pause the video, take a crack at the guided practice, and then check back in with us in just a couple minutes, and we'll see if they actually really are all that easy.
Okay.
Okay? Okay, so hopefully you took a couple minutes to try and figure out what these were on your own. So let's go through them real quick and see how you did. So I have C6H12. Let's do the ratio first.
So we start with the subscript, small numbers down below, so it's 6 to 12.
So I've got 6 to 12.
And that can reduce because 6/12 is 1/2.
Yeah.
Divide them both by 6.
Okay, so if I divide them, I've got 1/2 is my ratio.
So now I have 1C, 2 H's.
1C, 2 H's. That was nice, right?
So I can have the same empirical formulas but have a different molecular formula?
Yeah.
Okay.
Yeah. It's kind of wild. So, but that's why we make the differentiation between molecular and empirical formula, because you can have a whole big group of substances that all have different molecular formulas, but they have that same molar ratio.
That's kind of cool.
So I guess you can kind of group them together in like classes and stuff like that. If anybody's interested in organic chemistry, that's where this really comes into play. Okay, let's take a look at the other one.
Whoa. Nitrogen in there.
But all the same principles still apply, so we can still take
The
the
subscripts.
subscripts.
So it's just 2 to 4.
Okay.
And 2/4 is 1/2 again. So my empirical formula would be just 1 N and 2 O, so NO2.
There we go.
I like this.
Yeah, so, all right, last guided practice question. We have B2O6. So the ratios would be
2 over 6.
2 over 6.
Ooh, I like this one. This is different. Not 1/2. It's divided by 2, so it's 1/3.
Okay, 1/3. But figuring out the empirical formula is still the same, so
So it'd be 1B and 3 O's, so BO3.
there we go.
I like this.
Okay.
A lot.
Carry on. Work on practice. If you have any questions as you're going through it, let us know. Otherwise, keep on trucking. Bye.